Hey class, this is Mr. Win here with a video on 17.1 called Connecting Intercepts and Zeros. So we're actually going to skip this first page and we're going to go over to this section called Explain 1 in the middle of page 824. So for quadratic equations, we're going to learn about this thing called a zero. Okay? So a zero of a function is an x value that makes the value of the function 0. Okay. The zeros of a function are the x-intercepts of the graph of the function. A quadratic function can have 1, 2, or no zeros. Quadratic equations can be solved by graphing the related function of the equation. To write the related function, rewrite the quadratic equation so that it equals 0 on one side, replace the 0 with y. So this is a lot of words. We're going to talk about it, what it actually means when we do an example. Graph the related function and find the x-intercepts of the graph. Okay. X-intercepts. Again, the x-intercepts are your zeros. All right, the x value of the x-intercepts. The zeros of the function are the solutions to the original equation. So let's make sense of all of those words. Example 1, we want to solve by graphing this related function. So if I have an equation like this, I can solve for x. The way we can do that is we're first going to start by having this equal 0 on this side. Okay, so I want to get rid of this minus 3. I'm going to add 3 to both sides. Okay, negative 5 plus 3, negative 3 plus 3. That's going to get us 2x squared minus 2 is equal to 0. Okay, and so here's our new equation that we got here. Now, what we want to do, 2x squared minus 2 equals 0. We want to make this itself into a function that we can graph. So we're going to graph this. It's going to turn out to be a parabola. And when this says equals 0, that means I'm going to look for the points where the y value of that graph on the left side here is 0. Okay, so the related function, okay, kind of a weird word, but related function is the quadratic here, 2x squared minus 2, okay? So over here, they made a table of values for that function, and then they graphed all those points onto here, and they drew their parabola. Now the zeros of the function, those are the x-intercepts on my graph. So let me pull up the graph, zoom in a little bit. Okay. The x-intercepts, remember this is your x-axis. Your x-intercepts are the points where it's cutting through your x-axis. So here's a point that my curve is going to cut through my x-axis. Okay, it's intercepting the axis. Also, here's another point where it's intercepting the axis. So this quadratic, we would say it has 2 zeros. Okay, so not the number 0, but we call it a 0. Okay, the 0 is the x value, again, x value of those x-intercepts. So it's going to be negative 1 and 1, because my x value here is negative 1, and my x value here is 1. That means, actually, that our solutions to this equation that we started with, this equation up here, the solutions for x for that equation is x equals negative 1 and x equals 1. So we solved it by graphing that quadratic and finding the quote-unquote zeros of the function. Alright, so let's do another example. Here I have 6x plus 8 equals negative x squared. First thing I want to do is I want to get something equals 0. So I'm going to change this. Let's add x squared on both sides. So I have x squared plus 6x plus 8 is equal to 0. Okay. Now we can solve for the zeros since we have equals 0 on that side. Okay, we've got to have the equals 0. So our related function is, again, the quadratic on one of the sides. So x squared plus 6x plus 8. Is this equal to 0? Okay. I'm sorry. That's right. Okay, that's the equation we actually just got right there. I should have written it there. The related function is just the thing on the left side, so I'm going to say the function y is equal to x squared plus 6x plus 8. Okay, this is the blue thing. Now we can make a table to graph it. So I'm going to plug in -5 into x into each of those parts. So -5 squared, 25. Okay, let me just do that real quick. Okay, for -5, when I plug that in, I'm going to have -5 squared plus 6 times -5 plus 8. That's 25 minus 30 plus 8. -5 plus 8. I got 3. Okay, I want to plug in -4. And it's probably easier to use the calculator for this, but if you do that, just make sure to write your parentheses around your negative. Okay, I think I got 0 here if I plug in -3. Yeah, I need more space here, but it's fine. 9, 18, 8. Okay, I got -1 here. Let me do -2. Minus 12 plus 8. Maybe 0 again. And let's do -1. So I'm just plugging in these x values into the equation over here. 6. I got 3. Okay. So feel free to take the time to do that if you need. -5, 3. That point is going to be right about here. -4, 0, right here. -3, -1. -2, 0. And -1, 3. So here's my little parabola. I'm not sure why it's so small, but it's okay. Graph the points represented by the table and connect the points. Okay, we just did that. Now again, the zeros of the function. So here's my function. Again, the zeros, same thing as your x-intercept. This is where your y value of your graph is equal to 0. Okay. Alright, so this is where the y value is equal to 0. That's why we call it a 0. I'm going to have one right here is an intercept, and right here is an intercept. Oops. Okay, and those intercepts, my x value for this first point is -4. My x value for this point is -2. So my zeros of the function are going to be -4 and -2. And that means the solution to the equation that we started with, the x values that make this equation true, are -4 and -2. Feel free to pause and go back to review how we did any of those. These problems, number 3, or just number 3 itself, that's a good problem. Okay, set it equal to 0, graph your function, find your zeros. We're going to skip this explain to portion, and we're going to skip that one. Real quick, okay, I think I kind of like this one. If we're interpreting a quadratic model, we can do that, and we can see what the zeros mean. So, given the quadratic function model, answer the question. So, a dolphin jumps out of the water. Here's the quadratic function for it. Okay. And it models the dolphin's height above the water after t seconds. How long is the dolphin out of the water? Okay. So, level of water, we're going to put that at 0 feet. When the dolphin leaves and then re-enters the water again, its height is 0 feet. We're going to solve that equation to figure out when it's in and outside of the water. Okay, so here's your related function. 0 equals -16x squared plus 20x. Or sorry, the related function is y equals that quadratic. Here they graphed it for us, so it's a little bit easier to see when we look at the graph. We're going to look at this. This is representing my time. Okay. this is representing my height. So at 0 seconds, the dolphin is right at the surface of the water, right? Okay, here's your water. Here's my dolphin. Okay, not super great, but it's good enough. Sorry. I'm not sure why I'm spending time doing this, but it's okay. Here's my dolphin. Okay, it's at 0 feet right now. It's right at the water. Okay, let's say where the eyeball is. So it's gonna jump out of the water, and it's gonna come back down. Right here is the maximum height the dolphin is gonna go. Okay, the maximum height, also represented right here. If it takes a dolphin, let's see, I don't know how long it takes that dolphin. If it takes 2 seconds, for example, then t would be 2 right here. I'm not sure if it's actually 2, okay. But we want to figure out how long is it going to take? What's the time there and what's the time there? How long is it going to take for the dolphin to go back into the water, right? Okay, back into the water. Okay, there you go. Same water. Okay, so let's look here. They use the graph. Okay, so what they did is on the graphing calculator, there's a way to do it. Don't worry too much about it though. It's easier on Desmos. They use this trace button to tell me that actually right here, x is equal to 1.25, or really, we really want t for time. So that means it's going to take 1.25 seconds for the dolphin at this point in time to get there. Okay, so right here, t equals 0. Okay, halfway would be 0.625, I believe. Okay, so it takes 0.625 seconds for the dolphin to go all the way up, then 0.625 seconds to go down. So the whole way around is 1.25 seconds. Now the zeros of this function, again, the zeros are the x-intercepts. If here's my x-axis, okay, and my y-axis is over here, or something like that, my zeros are when the dolphin hits the water, okay, when the y is equal to 0, its height is 0. So hopefully that was a little fun example, and you can work through the rest of these other examples to help you get the idea of what a 0 is. There's one about baseball, okay, and that's it. Okay, so zeros are the x-intercepts of your function. There can be 2 of them. That's going to tell you the x values when y is equal to 0. Alright, hopefully you learned something. Have a good one, and think win-win.